Hello and welcome to the Alternate Physics. In this video, I will be showing you how I created the simulation of electric field using Python. So this is the project. But before going into the project, I want to show you the location of the project. For example, in this folder 01, I have created the project. Inside code, I have a couple of files, and inside this data folder, I have a couple of images. Now let's come to the main file. As you can see, the first line of the main file says import Pygame. This entire program is based on a module called Pygame. What is Pygame? Pygame basically helps you to write quickly, interactive programs. Okay, so let's start from the beginning. So I have defined a constant called size, which is equal to 1000. And this constant is being used in this line. When I initialize my program, the first thing that I do, I call Pygame init. This is a standard code. This initializes the Pygame module. Then I define a variable called screen. So basically I set the size of my screen. So I'm setting it to 1000 by 1000. So both the X and Y axes are of the size 1000 here. Okay. Then the next constant is FPS, which is 30. This means that each second my screen will be refreshed 30 times. So that is the frequency I can control. I'm defining this RGB value as black. This color will be used when I draw arrows later on, you will see. Okay, so here's the initialization code. As I already mentioned, I'm setting the title of the screen as electric field simulation. As you can see, it appears at the top. If I start it, here, electric field simulation. Then I'm setting Pygame mouse set visible 0. I don't want to show my cursor, the cursor of the mouse. Instead of the cursor, I will be showing the grabber from this location. Okay. So every time my cursor is on the screen, it's gonna be one of the image that will be loaded. As you can see, as I'm moving my cursor, is the released hand, or if I click here, it is the hand in the grab position. One of the two images will be loaded. So this is all about the initialization of Pygame. Then I create the background. These are standard code. You can go to Pygame documentation and you will see it. But the actual code starts from here, line 32. This is where I create the first object called fist. So fist is basically an object which is derived from another base class called sprite. In Pygame, sprites are used to define any kind of object, any kind of game object. For example, in my case, I have basically 3 types of game objects. I have the buttons here. I have this grabber which moves every time I move my the cursor, and I have these charge objects. So all of them are derived from sprite, and sprite class has its own methods which really helps you. So let's look into the code now of fist. This is the first object I'm going to discuss with you. So the constructor, in the constructor we first call the sprite constructor. Then I load the image. Every sprite has a member called rectangle, and that rectangle is represented by an image. So that image would be this freehand PNG which I have in my data folder. To load the image, I'm using utilities.loadImage. I have defined a function called loadImage, which I have defined in this file, utilities. What this function basically does, it takes a name and it takes a scale. The default value of the scale is 1. Anyway, whenever it gets a name, it searches that name in the data folder and it gets the full name, and it tries to load the image using this API, Pygame image load. Finally, using the scale, it transforms the image into a smaller variation. For example, the original image may be a larger one, its dimension may be very high, but using the scale, for example, I'm using a scale of 0.1, so it decreases the original image into like 10 times. And finally, it basically returns the getRectangle API. These are the two variables that returns basically. Okay, so now let's take a look at the Fist class. So once this Fist class is constructed, we have an image loaded, we have the rectangle variable, we also have a state called grip. Then there are a couple of APIs, member APIs we have with the Fist class. The first API is this update. So every time I move the mouse, as you can see, the grabber moves with it. So this update API is responsible for it. What it is doing, it is getting the position of the mouse and it is repositioning itself with that position. The next API is grab. So this API takes a target object and it does two things basically. Whenever this API is called, it loads the grab.png. Okay, this second PNG. As you can see, for example, if I grab this, if I click and hold, you have seen the image change from the freehand image to the grab image. So this grab API is doing that. The second thing it does, it basically checks whether the territory of the grabber and the target object, in this case it may be one of the charge, whether they are colliding with each other, whether they are in the same territory or not. So if they are, it will return true, otherwise it will just return false. Then the last API is release. This is a very simple API. Whenever this is called, the state of grip changes from 1 to 0, and the image also changes back to the original one, which is the freehand. Okay, next we are going to take a look at this list called charges. I am initializing this list with single charge at the start of the program. And the definition of this object called charge is in this file called object.py. So let's take a look at this class, charge. So similar to Fist, charge is also derived from sprite, and every charge object will have basically three information. It's coordinates, x and y, and the type of charge. So when we construct a charge object, if the type of the charge is positive, then the image which is loaded is plus.png, and this image is present in this data folder. For example, I have two PNGs, plus and minus. So if it's like positive, it's plus, otherwise it's minus. I am using a scale of 0.2. Then the information x and y coordinate I am keeping with the object itself, the charge type. Other than that, there is another state called locked. Initially, the locked is 0. The role of lock is this. I mean, you may have seen that whenever I'm grabbing a charge object and I'm moving my mouse, the charge moves with the grabber. So in that state, the charge is actually in a locked position. Then there are a couple of other APIs here which are pretty straightforward. We have get charge sign. It's going to be +1 for positive, otherwise -1. Get position will just return the XY coordinate. Then we have two APIs, lock and unlock, to set the lock state. I think the last two APIs are the most important. We have an API called update. I'll first talk about this. So what update will do, if the charge is locked, it will call follow Fist. Otherwise, it won't do anything. Only in case of locked, it will follow the Fist. How? So what it does is that it gets the position of the mouse and it updates its own x and y coordinate with that position, and it repositions the rectangle, that game object that charge represents, to the new position. That's how it does it. Okay, now let's take a look at the list of buttons. So I have a list called buttons where I am initializing three types of buttons: positive, negative, and undo. The class is defined in a file called buttons again, and as usual it is also derived from sprite object. Based on the button type, it loads positive, undo, or negative png, whatever. And the only thing that I need from this class is that the type of button, because in the application I'm gonna be clicking one of the button and I need to know which button was clicked. So it's this API is just gonna return the button type. Okay, now let's take a look at the actual game objects that we create. So after we define this fist object, then charges, and the list of buttons, we actually need to create the sprite objects, those game objects that are eventually going to be rendered into the screen. So I have defined new variables: all charges, all buttons, and all fists. And what they do, I'm calling the render plane API from Pygame Sprite, and I'm sending these objects to them. I have also some variables. The first variable is run. So eventually what I'm going to do, I'm going to enter a while loop when this program runs, and the while loop is going to run continuously, and this flag run is going to track whether I want to be inside that loop or I want to exit the loop. So the moment I make it false, it's just gonna exit the loop. Then I have a flag called event changed and old position. The reason I'm keeping these two information to do some optimization in my code. I do not want to let's say render my screen every time. I only want to render it when something happened. For example, I move my cursor or I click a button. So these two variables are gonna help me achieve that. Then I have actually moved it down to below to make it more understandable. The FPS, the frame per second. So this basically controls the frequency of screen refresh. For example, now it's set to 30. If I change it to, let's say, 10 and run my program, let's see what happens. As you can see, the rendering has a bit slowed down. As I'm moving things, it doesn't update so fast. I can make it even slower by lowering the FPS. It's even slow, very slow, very slow. But if I make it like something like 60, it will be smooth. Yeah, that's the thing. So yeah, this is where the loop starts, and this is the most important piece of code, because as the program is going to enter the while loop, whenever something happens, we need to catch that information. So Pygame allows you to write a code like Pygame has this event called this model called event. So you can get the kind of event that happened. And event has this thing called type. So if the type is quit, if I quit the program, I'm just gonna make run as false. But for me, the most important events are mouse. So I will be doing left click down or up. For example, if I'm moving a charge, what I'm gonna do, I'm just gonna move. I'm gonna do a down click of my I don't know what the hell am I saying, but yeah, I mean mouse button down and mouse button up basically means that left clicking your mouse and releasing your mouse. So let's discuss what happens when I left click. So this is where it comes. The first thing that I'm going to check is I'm going to go over all the buttons first. I want to see whether I'm clicking any of the buttons. So I have my fist object, right? And I told you that it had a API called grab, and it takes an object. So in this case, it takes one of the buttons. And this grab API, I told you earlier that this API is going to basically check whether those two objects are on top of each other. So if my mouse is on, let's say, that positive button, and I click there, this guy will become true. So here I will know that, okay, it has actually clicked this current object, this current button. And then from that button information, I'm going to get the button type. If the type is positive, that means I'm clicking a positive button. So what I want to do in that case, I want to create a new charge object. At the center, 500, 500, because my screen size is 1000 and the type of the charge will be positive. And what I'm going to do, I'm going to add that charge to the list, because I defined a list called charges here, right? So after every time I click on this positive button, a new positive charge will be created and it will be added to the list. And similarly for negative and for undo also. So whenever I click undo, the list will be popped because it's a stacked. So the last item which was added to the list, it will be popped out of the list, and then we will have one less. Then it's after we add into the charges list, this is an instance where event has changed, and then if none of the buttons are basically grabbed, this means that the fist is released. And once this thing is done, then I loop over all the charges. I mean, I may eventually click on top of one of the charges, right? So I also check whether I'm clicking on a charge. If that is true, what I do, I lock that charge. I told you that the charge object has an API called lock. It goes into the lock state. So whenever it's in the lock state, it just follows the fist. So that's what happens. I mean, if I'm clicking on top of a charge, I lock it and I say that event has changed. This is a serious situation. You need to do something. And finally, what happens when I release the left click? Like I clicked and then I'm releasing my left click. So in that case also, there will be an event fired by the program, and it will be called mouse button up. So in that case, what I do, I usually release all the charges. I mean, if one of the charges, this is a bit not optimized, I know, but I just unlock all the charges and I also release the fist. Basically, I go to the default state. So this is how the program basically runs from the object point of view. If you talk about the buttons and the charge, in the next section I'm going to be discussing how I'm drawing the arrow. But from the UI perspective, how these events are changing, this is the loop that basically is doing it. Okay, so once this event part is done, if something happened, my code will come here, right? And I have added some optimization here. I want to process inside the while loop if either the mouse position has changed or some event has happened. Otherwise, I'm just going to continue I will just stay in that loop, okay, forever. I'm not going to do any calculation. So if this code block, if this checkpoint is crossed and we come to this part, it means that something has really happened. Some event has happened and we need to redraw the electric field onto the screen. Now, how do I draw the electric field? So, as you know, the screen size is 1000 by 1000. I have divided the screen into a grid of 40 by 40. So that means each point is at a distance of 25 from each other. So I have added 2 for loops here where, you know, the increment at each step is going to be 25. So the value of x is going to start from 0, 25, 50, and so on. I can change this grid size. Let's say I make it 50 or something. You'll immediately see the effect on, as you see now, the number of points in the x direction are very less. So let's change it back to 25. So as this loop is going to be running at every instance, I am at one of the point of that 40 by 40 grid, right? I have the x and y coordinate. I have to be careful about the y coordinate because the positive value of y actually means at the negative direction in the coordinate system. So I have to meaning for y. D means display coordinate and y is the actual coordinate. So what I really do with this x and y data is that I call this API, calculate electric field direction and magnitude, and I have defined this API in a file called engine. So this file is going to handle all the physics part. Okay. So this API is going to get the coordinate of the point, and it's also going to get the charges, because in the application I have created maybe like 2, 3, 4, 5, God knows how many charges, right? So I'm going to send all the charges to this API, and I'm going to tell him like calculate the electric field for me at that point. So the strategy is very simple. I want to calculate the x and y components of the electric field for all charges, not a single charge, all the charges, and add them up. So what I do, I loop over all the charges. I find the position of that current charge. Okay? So once I get the position, I define it like x2 and y2. I just calculate the displacement vector dx and dy. Pretty simple. From that, I calculate the distance with my current point and the charge, which is like the radius, right? Root over dx square plus dy square. I have added some, check if the radius is very low. I don't want to proceed because it's going to result in extremely long arrows and all. So eventually, what I really do is that I also calculate the unit vector from my current point to the charge. This will help me calculate the x and y components. Then this is the heart of the simulation, which is directly taken from Coulomb's law. So Q1 and Q2, all the charges are of the same type. So Q1, Q2, 1 by 4 pi epsilon naught, that constant part I'm taking as, how much is it that? It's 4,000 K. This basically determines the strength of the field. Okay, if I change this value from 400 to let's say like 800, you will see longer arrows all over. You see, I can change it even more. I mean, like now it's 4 million. You see, so long arrows, man. Yeah. So this part is taken directly from Coulomb's law, and this gives me the magnitude of the electric field. And using the unit vectors ux and uy, I calculate the components like for that particular charge at that point. And finally, what I do is I just add them up in this variable ex. Okay? So once this loop is over, ex and ey, they are going to contain the resultant electric field, the x and y components of the resultant electric fields, right? So I want to calculate the magnitude of that resultant field. So I use this formula again, root over ex square plus ey square. And I also want to calculate the unit vectors of the resultant electric field. So again, I recalculate ux and uy, and I finally return this 4 information, okay, in my main. So I got the values, my ux, like these are the directions of the electric field and the magnitude of the electric field. What I have to do now is a very simple thing. I have a screen, I have a point. I just need to draw an arrow whose length is going to be proportional to the magnitude of the electric field and whose direction is going to be determined by ux and uy. So I define a variable called length, which is equal to the magnitude. And if this length is like too long, I don't want to have like extremely long arrows on my screen. It's gonna look super ugly. The max length is gonna be, which I'm gonna allow, is 50. And then my next job is I need to calculate. See, a line, to draw any line, you need the end point and the start point, right? X and Y are end points, but I also need the head. So I have also again written another API called calculate head and tail, which is going to take the unit vectors and the xy points, and it's just going to give me a new, head. I mean, new coordinates, head and tail. I'm basically, so I'm using x and y as like the center point. I'm just calculating like both head and tail based on the length. Okay. Then I also need to draw the arrow. You have the left and right side of the arrow. So I'm doing, I'm just taking the middle point, and rotating them by an angle of 165. So if this angle is like, if I change it to, let's say, 120 or something, you will see the shape of the arrow changes. So I find out that 165 looks the best, okay, for my arrow. So yeah, so once I have all the information, I have the head, the tail, and the right and left points of the arrowhead, and I have also the width. All I need to do is draw 3 lines, just these 3 lines. That's it. And I draw these 3 lines at each and every point. I'm not drawing arrow, I'm just drawing lines. Okay, so this loop is gonna, this for loop is gonna run over all those 40 by 40 points, and it's gonna draw 3 lines on each one of them. That's what I'm doing. And finally the code ends. Like finally I just draw all the game objects, all the charges, the fits, the buttons on the screen. And this loop runs forever until this program is running. So yeah, so this is how I created this simulation. It's pretty simple, right? And it's beautiful. Thank you for watching. Thank you.